If you'll recall from earlier, we used the multiply mode as a way of knocking out whites so that you could see what's below them. And we would use this normally in the real world if we had something on like black ink on a white piece of paper, some doodle that somebody wrote, and we wanted to knock out that white, no problem. Simply set it to multiply, voila, it knocks it out. Now, one thing we didn't talk a lot about is what happens if you're using multiply on things that aren't pure pigments or white or black. So if we get our move tool, if we move this gentleman here, you can see that they become darker as they cross over each other. And this will be true for any sort of image that we place in. If we have this lady in multiply mode, the white background's knocked out, and wherever she is, she's kind of burned onto the image. Now, this brings up a question that I had glossed over back when I was a student, which is really, what is it doing? I'd always assumed that multiply was just multiplying the pixels together, hence the term multiply. And this was somewhat reinforced by a few of the other layers and how they function, such as divide would be dividing these things out. So for example, if I went to divide, I assumed that division was happening. And then I also made some assumptions, like linear dodge add would most likely be adding pixels together. And then I just left it at that and didn't think about it too much. And then I thought, well, subtract probably just subtracts the colors. So somewhere in here we do have a subtract. My assumption was that it was just subtracting. Had I thought about it a little more deeply, I would have realized how very wrong I was. There's actually a twist to this. So let's make two new layers. And I'm going to fill these layers with just black and white, but with different amounts of brightness. Now, if you remember, 255 is the maximum that we could get in anything, because if we use 255 all down the line, we get pure white. So let's start out with about 200 all down the line instead, which, as we can see, gives us a brightness of about 78%. I'll fill, whoops, wrong layer. Don't want to fill that one in. I'll fill in this layer. And let's say that I came in with something like 70 all down the line, which gives us a darker gray. Now, presumably, if I were to multiply these two numbers together, 70 times 200 is going to get pretty big pretty fast. So let's just bring up this calculator. 70 times 200. 14,000. Well, that's huge. We know what happens to anything that it goes above 255. It's clipped to white. In other words, it becomes 255 and that's it. Anything below 255, or sorry, anything below 0 would clip to black. In other words, it would just be made black. So let's go ahead and test this. If I simply take this and move it to multiply mode, we should get some very bright colors, but instead it becomes darker. Now, this from experience makes sense. If we click on here, we can see that we in fact have 55 all down the line. Now, this makes sense because we know multiplies in the darkening modes. But that begs the question, why is it called multiply if it's not actually multiplying things? And the answer is a little strange. It actually is multiplying things with a slight twist to it. It's multiplying things after they're standardized. So this is using something called standardized values. And what that means is that it's converting each number on the red channel, the green channel, and the blue channel from 0 to 255 to a percentage. And then it's performing the multiplication action or the subtraction action or the addition action or the division action. So how does it do all that? Well, if you'll recall, we have a red channel, a green channel, and a blue channel, and each of those can have a luminance value of 0 to 255, where 0 is black and 255 is bright white. And if you recall a little further, that means that mid-tone gray is around 128 or 127, somewhere in there, depending on where the scale is sliding. So that grants us a whole luminance value going on for each of these channels, and then when you mix them together, you get color. So for this example, we'll be sticking with black and white, but keep in mind that each of these channels will be undergoing the standardization process before being combined with the other channel. So if we were to think of it this way, we have some amount of one layer that's been standardized. In other words, it's been divided by 255 for each of these, divided by 255, divided by 255. And then in turn, it will have some blending effects pixel by pixel by standardized things over here. So let's look at what all of that means, because this is just kind of looking like a big mathematical mess, right? So let me pop open a new one. So let's say that we standardized these before we did the mathematics. So instead of just taking our active layer and multiplying it by our background layer, we're instead going to take a normalized active layer, which will essentially be our active layer's pixels divided by 255, and then multiplying that by our background layer, which has also been divided pixel by pixel, channel by channel by 255. And then those results will be whatever's happening. So we used 200 and we used 70. So what will that equal? Well, I think it's time to break out the old calculator to figure this one out. And fortunately, computers are generally equipped with calculators. So let's pop this thing in. Let's say that we had, well, let's start a little slow. Let's say we had 200 divided by 255. We would get around 78% of our total possible brightness. And let's see where we were here. Here's our 200. Well, look at that. Our brightness is at 78%. So I'm going to guess that our 70 will end up becoming around 27% brightness. Let's see if that's the case. We have 70 divided by 255. Oh, look at that. We end up with 27%. Pretty much what we were expecting. So let's do our multiplication on it. And we will do our 70 divided by 255. And then we will come in and edit this because we actually don't want it to calculate right away. Just a moment. Boom. Type that out. Copy that over. Let's paste this in. Hit return. So its claim is that we'll have there'll be 0.2153. If we round that up to the first two numbers, that will end up being about 22%. So let's see if this is accurate. Let me switch this to multiply. Pop in. Would you look at that? 22% brightness. So that's how multiply is working, and this is actually true for everything. So all of these will end up using the standardized values before performing their calculations. So if we were to do subtraction, for example, would standardize it. So in other words, it would essentially be using the brightness values in here before it subtracts. So let's take a quick look at how that functions. So subtract should be as simple as the top layer minus the bottom layer. So let's take a look at what those values are again when they're not in multiply. We should one more time have 27% on the top and have a 78% on the bottom. Let's switch it to subtract. And now we get a 51%. And we can always double check those numbers real quick. Oops, let me clear that out. All right, so 70 divided by 255, one more time, it's about 27 points, so that's about 0.27. And I keep hitting the wrong clear button there. Whereas 200 divided by 255, there we go, is about 0.78, which makes sense. That's about what we got. So subtraction will take the background layer, and then it will have the active layer subtracted from it. So let's see what we get. So essentially that should be the 0.78 subtracted from it will be the the 0.27. So the claim is that we should get about 0.51. Let's see if that's the case. It is 0.51, 51%. There you have it. That's subtraction. So that's the math behind all of these. Anytime it's working with these pixels, it's going to standardize them first. So things like division will go white pretty quickly, whereas things like multiply will go dark pretty quickly. Things like add will go white pretty quickly and clip out, and things like subtract will get darker and eventually clip out. Now, the nice thing about multiply is that it doesn't actually clip, because you're multiplying two percentages together. You're not going to really end up with any white clipping, because things will just get darker and darker. Eventually it will go to black, and then you're set. That's that. And since the only way to get to black is to have something that's already black in the mix, then there you have it. You've got multiply. It's an amazing tool. So that's the case for those. But let me say one other thing. Let me duplicate this real quick. All right, now we'll have one we can mess up and not worry about. I'll just pick a nice color, maybe one of these reds, be a little more vibrant. All right, and we'll get our brush. We'll set our brush to something like screen, and we'll cover all these in a minute. But notice how bright this is. If we go over it again and again and again, it will become brighter every single time that we do it, and eventually we'll reach some level of white. Now, if we were to set this to normal mode for our brush instead of screen, and do this on a layer that is set to screen, if we were to brush as many times as we want, we'll never reach this brightness, that level of brightness. And the reason for that is that each one of these brush strokes is essentially a new layer being built up on top of the previous one, and being set to screen again and again and again. And eventually, by doing that, you'll end up with the same level of brightness. So watch out for that when you're painting. It won't be exactly the same as when you're painting with the blending mode. It won't be exactly the same as painting on a layer in a blending mode. So in other words, if you're applying effects, make sure you know that there will be a slightly different application, or applying blending modes as an effect. Keep in mind that there will be a slightly different application depending on how you're applying that. So when we were doing things earlier in the semester with the brush set to overlay mode and then painting in overlay mode, we could go over again and again and would build it up more and more. And that's because of the way that the brush stroke behaves. Each one is a new application of the effect on the previous step. All right, with all that in mind, let's go ahead and get into how the darkening modes work. And let me just clear out some of this stuff so that we have a nice, fresh darkening section to work with. All right, see you next video. One last thing before we go on, I forgot to mention the reason I was able to use brightness in those examples as what the correct percentage was simply because we were working in black and white. Since there were no colors, saturation or hue in there, we didn't have to do calculations across red, green, and blue individually. We only had to do it one time, and brightness is just exactly the same concept. Brightness is a percentage of 0 black to 0%, which is 0 luminance levels, which is black, to 100% luminance levels, which is 255. So in other words, standardizing a gray will get the same percentage that the brightness is. That's why we're able to re-reference the brightness to see if the mathematics was correct. This would have been a lot more difficult had we been in different colors that had different amounts going in, because the saturation and the hue have an effect in there. They're have an effect. They're not directly related to red or green or blue. They're related to the combination of red, green, and blue. So that's why we were using gray, because the completely desaturated grays have a direct correlation to the brightness. 100% brightness, 255 all down the line, 0% brightness, 0 all down the line. That's why we're able to do that. Okay, finally now we can go on to darkening videos. Sorry about that. See you in a minute.